we are now ready to start placing our collectibles into our level and start dealing with non-player character, our artificial intelligence. But before we do that, we need to know where the AI will be able to navigate. And based on that navigation area, we are going to be able to then place our collectibles. We do not want to place crates where the player or the non-player character will not be able to reach. So for that, we're going to create a navigation map. We will first start using our existing collision map and turn it into a navigation mesh. Once we have the navigation mesh, we can then create a map that is going to tell us the exact area where the non-player character can and cannot go, and where, when a robot die, where can it respawn. So what we're going to do, we are going to go back on our default layout here, and I'm going to go under the outliner and type COLL to bring in my collision map. I'm going to temporarily make it visible and select it. And next, I am going to go under the properties and navigation. I already have a default ability created. I am now going to build the navigation mesh by clicking. This is giving me a rough outline of all the polygon that will actually be then converted into a map. So I am going to slightly shrink down the size here of the cell. I'm going to put something like 0.2 of size and 0.3 of height. Next, I am going to create a new navigation map. I am going to put it a friendly color here, something like that. The number of tiles, the amount of tile size will be drastically reduced as I want to deal with, I prefer to deal with a larger amount of tile that are smaller. So like that, I'm going to be able to then remove the tiles that will be generated that are unreachable by the non-player character. Next, I am going to move on to my agent settings. And for my walkable radius, I am going to use the same radius that we used earlier for our bot controller, the radius of our capsule, which was 0.3. And for the rest of the settings, I'm going to leave them as they are. We could definitely tweak more parameters to have a better navigation map, but just leave it as default for now. And we are going to also click Build a BVH tree to accelerate the operation later on that we're going to effectuate on that navigation map. Now I'm going to build the map, which will take a second. And you can see now that my map, the overlay, the blue overlay here is telling me where my AI, my player, non-player character will be able to go. As you can see, there's a few things that are not right here. There is absolutely no way we want the character to be able to reach this path here. So these tiles will have to be removed. On the other side, the other hand, we are also going to respawn when a robot dies. We're going to give a random point on that map where it will be respawned. Like in this example here, we have the rock. We do not want the player to restart in the middle of the rock and after that be stuck there forever, because there is, as you can see here, there's an invisible wall from our collision map that is going to prevent it to go further. So what we're going to do, we are going to need to adjust manually the tile cache. Obviously, this is already pretty good. It's at 90% okay, but we're going to need to tweak it a bit to make it fully reusable while we are playing. So we are going to enter the navigation edit mode here. And on the left side, I'm going to select my tool that is going to be my manage tile cache. I want to actually remove some of these tiles. So I'm going to select remove an existing tile. And I'm going to select the navigation map that I want to work with. This one over here, we only have one anyway here. And as I do that, as I pass my mouse on my viewport, you can see that I have these columns that are generated that are highlighting me which tile I'm actually selecting. So like in this example, we are going to get rid of all the tiles that are located in this area. I'm going to push 1 to go from the top view, and I'm going to click on each and every one of them, removing them one by one as I do not want them to be part of my navigation map. We are going to process the whole level like this, removing also tile that have been generated in between walls. Like here, we are having a wall for our corridor. This will have a thickness And because of the way the navigation, the collision map is created, the navigation map have slight part of it that have been small part of it that create actually a tile, and we want to remove these as well. So it's a bit of tedious work, but it's not rocket science. It doesn't have to be that precise. So at any time while you're doing this, also, if you miss your shot, like an example, while moving, I'm going to remove that tile. Simply change the tool to be create a new tile. And after that, hover your mouse over it and click to reconstruct it. So I am going to process my whole level and removing all the unnecessary tile and all the paths that cannot be reached by the player. And we will then place our collectibles. And we are back. I think I clean up the map pretty good. I go from the top view most of the time, and using the middle mouse button, I simply pan around my scene and get rid of all the tiles, and this one also can be gone. I get rid of all the tiles that are not going to be reachable, or where I don't want the player to simply restart and then be stuck forever. So now we have the exact location where we can place our crates. So what we're going to do, let's try to be a bit strategic, but the main process will be very simple. We are going to go back in selection mode, and what we're going to do, we are going to select the crate and simply hit Shift and D, and holding the G button, the grab button, we are going to, with our new created crate here, let's select it. Just to give an example, I'm way too close. Here, I'm going to select it, and I'm simply going to drag it where I want it to be. So like an example, this one is a ammo crate, and I'm going to hold the G button under my viewport, and I'm simply going to drag it here. Be mindful of the roof here. So like in this example, if I start dragging, I'm going to go on top of the roof. I need to make sure that I'm going to stay on my actual ground, my blue area here, my blue delimitation here. So I'm going to repeat the process and create 10 ammo crate and 10 health crate. And after that, we're going to be able to test our map. So finally, I end up placing 16 crate of ammo and 16 crate of health, just for the sake of having our player and non-player character explore our entire level and make the gunfights a bit more interesting. So next, I want to test my scene. So what I'm going to do is I'm first going to re-enable those collectibles that we have turned off earlier. So I'm going to go under the coding layout and collectibles, and at the top of the file, I'm going to add the following line. If not app is running, then return end. So if my application is not running, skip the initialization and do not update those crates. So I'm going to build and save. Next, I'm going to go under scene and re-enable the collectible script here by clicking the little check. Done. And next, I am going to go under properties and application, and I'm going to make sure that my startup scene is actually MicroBots. I'm also going to enable full screen here. So as soon as I push the start button, I'm going to go full screen. I am going to save that. And next, I am going to enable the performance HUD, and I'm going to have a look at the performance of my scene by first analyzing the frame rate. So we are going to play, and everything seems to work correctly. If I go pick my ammo crate, it is fine. I can shoot, move around, and everything seems to work properly. The frame rate is not really great at the moment. We can see that we are at 40, and if I take a wider shot of my scene here, we can see that the performance is sinking drastically. The more wider the view I'm having, the less performance I'm having, up to the point that we are at 30 frames per second here. So let's try to analyze what is going on. We are going to switch the type of performance HUD to be frame stats. That is going to give us both CPU and GPU usage. And right away, we can see that right on top, our CPU is at 24 milliseconds, which is alarming. The GPU is basically okay. I got a 4-year-old video card here. So this is the basically the kind of stats that I would expect from that card. What I'm not expecting is this 24, 25 millisecond of CPU. It is coming while rendering the geometry render layer. And if we dig a bit deeper, I am going to push a spacebar here to have application view and change once again the performance HUD to be CPU plus trace. The trace is going to accumulate the function call for the last second. So I'm going to click on that and let it run for a second. And we can see that on top, we got our application drop. Nothing very surprising here. And the second one though, we are having on every frame, we are having a huge amount of millisecond that it's spent on our geometry script. So what's going on that geometry script? I am going to stop the application and stop my performance HUD. And I'm going to go on the renderer and geometry and pull my geometry script. So at the top of the file, I'm setting a few states here, picking up some object and matrix. I am assigning the projector matrix, just simply grabbing them, nothing serious here. Setting a few shader uniform, nothing serious as well. Here, now we start having some serious calculation here that is happening. We are calculating the matrix for each and every object. And we are also calculating matrix for our motion blur. And we are doing this at a tremendous amount per second. Of course, a quick fix would be to simply use CC++ to accelerate the whole process. But if we take a quick look at the construction of an object, the problem that we're having right now is we're having too many objects that are calling this function on a per frame basis. Our goal will be to reduce the amount of frame that are by culling them only to keep the one that are visible on screen, and that matters. By default, NRG provide a simple scene management that simply queue objects that are within the viewport point of view. And other solutions out there are basically providing you in the background scene management system that are maybe not necessarily good for the type of project that you're having. I always find it better to implement my own one, as I know more what I'm doing than the one who produced the software and basically think for me what is good. So obviously what we're having is too many objects on screen. If we take a look at the construction of that specific module here on my corridor, we can see that there is 4 material that are assigned, and we have multiple modules that are all connected together. An obvious way to optimize will be to join that geometry here and create that this corridor is actually made of 3 or maybe 4 pieces. So we are going to have less object state change, and we can get more performance very easily like that. Obviously, there's a ton of optimization that can be done, in this scene. This is just a tutorial. I just want to display and show how things work. But if that was a real game, we would really go a different way. How we can fix that right now. So what we can do is using occlusion. Occlusion is a relatively cheap and a very effective way of culling extra object on screen. So to do that, I am going to select my sector here, which is basically my terrain. And I am going to create a copy of that terrain. So I'm going to go under Object and Duplicate. I am going to type Sector. So my duplicate is Sector 0. With Sector 0 selected, I'm going to go under Selection, Convert to an Occluder. So I am going to try to run my application another time with my occlusion on. But before, I want to have a preview of what is going to happen. So as I go in my viewport in edit mode, you can see that now all these geometry that are occluded by the terrain will not be drawn on screen. At this point, at the location that I am having 59 objects that are currently drawn on screen. And if I turn off the occlusion, I'm at 215. So huge improvement right there. And if I also notice that my robot is still part of my scene. So I'm going to click but because we re-enabled it earlier. So I am going to move it out of my geometry render layer, clicking like that. That should also help a bit. And now this is great, but as we are noticing here in the example, the corridor here does not occlude anything because it is not part of the terrain. We already call a huge amount of geometry just by adding this simple occlusion object on the terrain, but we need a bit more of extra here for the corridor and the hanger that are located there. For that, we're going to use a map. I am going to go back in Blender. If you remember, we have dealt with the collision map earlier, and this time we are going to put the occlusion map visible. So we have a dedicated map that is a cheap and rough outline of the corridors that we're having and the hanger here that is going to also help us to call a lot of geometry. So I'm going to select this. I'm going to go under File, Export, and Collada, MicroBots, and under the main tab selection only, Export. Back to my NRG editor, I am going to go under MicroBots and Assets, Import, and Desktop in my case, MicroBots, and pick my Collada file, open that up. I'm only interested in the geometry and nothing else. Material off, animation off, skeleton off. And I simply want this geometry to be placed on my geometry render layer. So I'm going to import, and I am going to go under my outliner and type COLL to select my collision map. And I'm going to repeat the process. I am occlusion map, OCC, occlusion map. And I am now going to repeat the process and convert this occlusion map into a occluder. So selection, convert to an occluder. And right away, we can see that we got more geometry that get called by this occlusion map here. So if we check the amount with and without, right now with the terrain and our occlusion map, basically only 26 objects left. If I turn it off, we are already at 151 just with that corridor occlusion map. So a combination of our terrain occlusion map plus the corridor and hanger occlusion map drop down the amount of object to 26. So we could definitely expect a huge performance gain from 200 something object all the way down to 26. So we are going to save that and we are going to have another run at it with our frame rate on. I am going to push Shift before I push the start button to save, just like that. And now if we are checking our frame rate, we are basically near 100, sometimes over 100, even with larger shot of our level as things get called away. Of course, there's also performance gain that you can expect when your application will be published. Right now, all the scripts that are running are basically having also debug information. But once you publish your application, they will be built for release. So you can expect up to 5 times. It happened that I've seen myself up to 5 times more performance just by compiling a script in release. So this is it. We have basically our basic demo scene that it's working, and we are now, and it's performing relatively okay. And now we are going to move on and start implementing the AI for our non-player character to start having interesting gunfights. Before moving on with our non-player character code, I noticed 2 issues when I was actually preparing the next session. We are having the issue if I push spacebar here and push play, we're having an issue of the terrain, occluding the terrain. If I bring my camera very close here, you can see that I'm losing my terrain and I am losing my gun as well. This is obviously not what we want. So we are going to fix that. And also I noticed while creating the occluder, since we create a duplicate of our sector 1, our terrain, we forgot to turn off that the occluder draw in the right depth render layer. So I'm going to fix that right away. I'm going to type SEC with the scope on scene. I am going to select my occluder, sector 0, and under object property, I'm going to scroll down and disable the right depth render layer here, which should also give me a substantial gain of performance. Now, to fix the sector 1, the terrain problem, I'm going to select sector 1 and I am going to go up here, and under clip precision, I am going to change the clip precision to be custom. So like that, I am specifying myself the actual camera distance. The camera distance, if it's greater than 0, it means that the object will be drawn less or equal to 0. Less than 0, it is occluded, and 0, it is simply not drawn on screen. So if I push 0, it means it will never be drawn. And if I set 1, it will always be drawn. Since our terrain is visible almost at 90-something% of the time, it would make sense to set that to 1. And like that, that would avoid also my problem of the terrain occluding the terrain. Now, the same thing will apply for our blaster. So we are going to change that as well. Under blaster, clip precision and custom, it is set to 1 by default. And like this, my blaster and my terrain are not occluded by the actual terrain itself and are always visible on screen. Worth mentioning also, I was testing offline performances. Since I forgot to mention it in the previous video, said that since I am also using a recording software and also that little tool here for displaying the key, stroke, and the mouse, the performance is actually greater than it is compared to the one that is actually recorded on video. So also having multiple 3D application open at the same time will affect the overall performance of the NRG editor. So with that said, we can now move on and start coding our non-player